There has been a tool that I've wanted in my workshop for years, but up until now, nobody's built it. I felt that there was such a need that I was actually going to build one for myself. It's finally here. Stick around. This is the foundation of the tool that I'm talking about, a metal cutting chop saw. You put your material in here, pull it down, it cuts the metal off. When you want to do a 45 or anything less than a 45, for this model, you put your material in and then clamp it this way. The issue is that this part of the saw doesn't turn, the base has to. So like right now, if I have a real long piece of material, it's going to go banging into that bench. So what I have to do is turn my saw base to make it line up parallel with the length of my room, then I can cut it. So I'm always sliding this base around. This is my wood cutting saw. I've got it set up on my bench over here. I run long pieces of material. They're all supported all the way down the length of my bench. If I want to do a miter cut, I just turn this. The fence stays parallel with the bench. I can make my cut both directions and move on my way. I don't have to spin the saw around. Thankfully, somebody has figured this out. This is the Evolution Tools 355 MCS, and I am stoked to show you this. It is about time that somebody in the industry finally implemented this idea, because this has been needed for so long, guys. Now you put your material on here. You can make a dual cut, so you can go on either side of 45. You don't have to change your workpiece. Your outfeed and infeed can be in the same direction. You're not spinning your base all around. You can cut it both ways. It's got locking detents at all the popular places, so you can see you're at 90. Then it detents again at 15. Probably, what, 22 and a half? Yep, 22 and a half, 30, and 45. So those are the locking detents, and then, like I said, you can lock it in at anywhere in between. So that's 19 degrees. Works just like most wood chop saws. Snug down the handle, and you're cutting it. What an awesome idea. I am thoroughly thrilled that somebody finally came up with this. This has been so needed in the industry for so long. So today, we're going to put this saw together. I'm going to talk about it. I'm going to show it to you guys, and we're going to cut some material because I am thrilled. I've taken everything out of the box just to spare you the details of that. You don't need to see it, but these are everything that you're going to get in your box, and it's very well packaged. I've laid everything out. This base looks to be like a cast aluminum base. It feels really stout. But one of the things that I'm seeing that I'm super impressed with, and I'm going to explain why, is that if you look at this saw next to my 380 CPS, I would almost dare say that this whole business end of this is probably this. It looks as though I can see all kinds of interchanging pieces that would interchange with one another. Well, why is that important? Well, that is important because, you know, 20 years down the road, you're going to want to replace parts on this just from normal wear and normal use. So if you've got multiple tools that have interchanging pieces and parts, like this handle looks to be like this handle from this saw, there's a pretty good chance that it'll be very easy to get parts for this saw 20, 30 years down the road when you need to start thinking about doing maintenance on this, or even sooner. You know, brushes is a regular common thing. You may drop something on it, damage a part, break a handle, need a switch. It's nice to know that you can get these parts and they're readily available. First thing we're going to look at is putting that saw head onto these. Now this is not a compound sliding saw. These have little detents in them for different positions of where you have your stock. We're going to talk about that here a little bit further in detail, but one of the first things you want to do is clean off the mating surfaces so that there's no dirt and debris. Make sure they're nice and clean and don't have any, you know, heavy oil or any contaminants on them. Clean them off while we're right here. Now if you look inside here, inside this back section here, these are what are called linear bearings, and I'm going to try to get you in there so you can see it. I don't know if you're able to get a good visual on that. These are far superior over a bushing for this application. And the reason for that, guys, that a linear bearing is far superior than a bushing is because a bushing needs to have a tight tolerance, okay? So if you have a tight tolerance and then you get some crud buildup along this right here, you may have to like force this into position. As you can see, you can hear the bearings actually moving. This allows for a tight tolerance, but still being able to move in and out. So this is a superior design. So with this on, we'll lock it in place. Then we're going to put this little stabilizer foot on the backside. I am thrilled to have this tool, guys, because I've been waiting for someone to build this. Like, it doesn't seem like it would be all that hard, but I don't know why nobody has done it up to this date. Evolution Tools is the only one doing this as far as I know, and this is incredible. The industry has needed this for a long time. I can easily rave about this saw before I even use it, because I already know how much I love this saw. And I have multiple other tools of Evolution. I've got this saw that you've seen me use in a recent video where I was cutting up aluminum. And I've got this tool, which I absolutely love. Now, guys, this is a magnetic drill. And I know it's probably hard to maybe justify spending that kind of money on a magnetic drill. But if you're looking to go and buy a drill press, I bought this drill press stand off Marketplace, and I think I paid like $75 for it. I cut the top of the head off, welded this plate onto it, and that's where my mag drill sits. And this is actually my drill press. I can run annular cutters, I can run regular drill bits, I can run hole saws, and you will never bog this thing down. This has so much power. If you guys are handy, I picked this up off a Marketplace for like 75 bucks. Set my mag drill right there. If you can't tell, guys, I get really excited about tools that just are awesome in the workshop, and just to be able to have a magnetic drill that does both duties is an added bonus. I've got to have a metal cutting chop saw in my workshop, but turning the saw base every time I need to make a cut for a long piece of material is a massive pain, and you can only cut in one direction. You can only cut to the left. This one doesn't do right and left miters. However, this one does, and this is going to be a game changer. These guys are going to lead other manufacturers to probably have to build it too, because these guys are obviously far ahead of where everybody else is right now in this. With that secured, this little snug down, now we can rotate this around. You can see this works just like any other chop saw now at this point. They've got the Allen wrench right here. It's actually got the right size that I could have used to tighten this down. So that's actually on there. I didn't even need to use my tool. It's got this for your blade changes and to snug down your fence or check any of the bolts that you need to tighten down. So everything you need is right in the tool they provide. I'm going to thread these little thumb screws in. Just turn it in a couple turns. We'll talk about what these are for here in a second. If you look right down inside here, there's a little ball bearing, like a little detent bearing, and there's also one on this other side right over here. This is part of their clamping system, and each of these little detent areas corresponds to that little ball bearing that's in there. It gives it just a positive place to lock into, and this is part of their clamping bar system, and I'll show you exactly how all this stuff works. So this will sit down like this. We'll talk here in a few minutes of why this is adjustable up and down, but for right now we're just going to drop it in, set it down to where it is. These are the material holding clamps, and they slide right on. We'll put one on over here. We'll put another one on over here. And as you can see, these are a quick clamp. They work just like any other clamp on the saw. You bring your material up, then just tighten it down, they clamp. These are some pads for holding the material on the bias. And I've talked about this quite a bit in some of my other videos. There's also a little ball detent on each of these that allows this to stay pressured onto there, so they hold onto it and give it a nice positive feel. And you also have a third one for an additional clamp that's included with it. It also has those little ball detents. See, it's got a nice knurled finish on it to give it good grip. That can be used to hold down your work as well. And that can fit in any of these 5 holes along the back of this tool, so that you can get your clamp as close as you need it to your work. And as you can see, it adjusts down quickly. Give it a turn and it's tight. You can do it over here as well on this side. This tool also comes with a blade, so you're not going to have to go out and buy a blade. This is just how it comes. It's in the package when you buy it. To loosen this arbor, you're going to want to turn it counterclockwise, so it's the normal direction as you would loosen anything else. You're going to use the tool that came with it. This is a 1-inch arbor, and it is directional blade. I have a lot of people ask me if they can put one of these blades on like a regular wood cutting chop saw like I just showed you. They may bolt on, but they won't last very long. Because a wood cutting blade or a wood cutting saw turns so much faster than this saw here, you'll just end up ruining not only the blade, but you'll probably end up ruining your saw too. So it's not worth it. You're better off having the right tool for the job. Because these blades aren't cheap, but they do last a long time if you take good care of them. So we pull this guard back in place. Now we could stop here, guys, and just start cutting with the saw. I'm going to go one step further, and I'm going to verify that this is cutting straight in all directions before we even attempt to cut any metal. Whenever you get a brand new saw, it's always a good idea to check it for accuracy. Check it for 90 degrees, check it for 90 degrees this way to make sure everything is on the money. And that way you won't be frustrated if things aren't right. This is an adjustable saw. You can adjust it to get it absolutely perfect. And most saws aren't perfect coming right out of the box, but we'll find out. Maybe this one is. This one has adjustments where you can adjust the 90 off the fence right here and here. It's identical to this saw. You do it the exact same way. You loosen that, and then you make sure this is all dialed in so it's a perfect 90-degree cut off the fence. It's great that they have this in here because you can make this saw perfectly accurate. You don't have to settle with something that's not quite perfect. These do get bumped around, especially if you're hauling them in your truck and you're using this on a job site or whatever. You want to make sure that this stays accurate all the time, and these adjustments allow you to do that. So the first thing I'll do, guys, is just pull this clamping system out of my way. And now I want to check that the blade is cutting perfectly straight up and down. So 90 degrees up and down to the table so that the blade isn't beveled either way. So I'm going to do that by setting a square on the table and bring this right down to it. And you can see that is perfect in alignment. We can't see any light through the side of that square. The next thing I like to do is make sure that both of these fences are in alignment to each other. Because if these aren't in alignment to each other, you can't get this base 90 degrees. So if this one is cocked off a little bit and this one is cocked the other way, and you 90 it this way, it's not going to be the same when you 90 it this way. Does that make sense? So first thing we need to do is make sure that this fence is perfectly in alignment to each other. The way I do that is, again, take a framing square and just stick it across both. There shouldn't be any rocking. Okay, so there is rocking. You can hear it. So that's saying that both of these aren't parallel with each other. Why is that? To adjust that, you'd turn these screws in behind here. So you can see how it's made, this saw. It's got a little groove that fits in. That looks like it's real tight to the front of the groove here, but we've got a gap right here. So let's take this fence here, loosen it up a little bit, get it back into adjustment. You probably wouldn't have to do this. I'm probably going way overboard with this saw. I look at it as this. If I spend a little bit of extra time now in getting this thing absolutely perfect, then I know no matter where I'm working on this saw, it'll always give me perfect results. So let's take this and bump this forward a little bit. There we go. Let me try snugging this down again. Now you can see, guys, there's no gap there. That's right tight. So let's give it that same try with that straight edge. All right, we're good on the back. I've got to move the front in a little bit. You see how we're real tight here? And can you see we got a little bit of a gap right there? But we're tight right here. If I take this square and slide it along, I'm nice and parallel along that. See how we got a little slight gap right here? So I got to pull this ahead just a little bit so it touches right there. Alright, watch this now, guys. Slide this over. Boom, that's like perfect. Look at that. And we keep sliding it over. Check it for wobble. That's perfect. No wobble. Check it up high. Good. Down low. Perfect. In the middle. Perfect. There is no wobble. So this fence is perfectly in alignment with one another. So now that we know that the fence is straight this way, no matter which side of the blade we go off from, it should continue to remain a 90. So we'll take another framing square and we'll bring the blade down to it and we'll verify that this is in perfect alignment. Look at that, guys. Ready? Here we go. Bring it in. Boom. Right there. That's it. And we didn't even have to adjust any of this. This is absolutely perfect. So before we start cutting, I want to talk about why these 3 detents are at the back. Your machine will come with this little chart. Look at it is in rows of this way. You're looking at it up and down. So this way, this way, this way. Each of these lines represent a position in this hole. This row here represents the back set of holes. The middle row represents the middle row of pins, and obviously the front row represent the front row of pins. We're all the way forward on this right now. That's representing the front row of pins. What this is telling us is if you've got a really tiny piece of material in the machine that's clamped right up against this portion of the saw, just, you know, something small right here, that you wouldn't want this machine in the front pin, you wouldn't want it in the back one, you want it all the way back, because it's showing that the center line of the saw blade is more in alignment to the center line of the material. If you were in the middle position, it's showing that the saw head would be a little too far forward compared to the material, and if you were all the way forward, the center line of the blade would be way ahead of the material. Here's the back detent, pull it ahead, there's the middle detent, pull it a little bit further forward, there's the front detent. For little material, we'd want to move this all the way back, snug that up. And that puts the center line of the blade, which the arbor center is right about here, in line with that fence. You can just kind of look at a few of the pictures. So let's say you were cutting some square tubing on the bias, you would want it in the middle position. If you wanted to laminate this little piece of paper, you could do that and just keep it close to your saw. But I don't know as if that's absolutely necessary, guys. I think you just use a little bit of common sense and you'll be doing yourself just fine. But again, guys, this is not to be used as a sliding miter saw. It's made to be locked in a position, snug down, and then you make your cut. So let's start making some cuts. We will get our cutting bar on the saw. Now, if you want to extend the life of your saw, listen to what I'm going to show you. I got some 1/4-inch plate here. You can see that's 1/4 inch right there. And you could cut this a couple different ways. One way is the right way, the other way is the wrong way. You could lay it in like this, cut it that way. That would be the wrong way. The better way would be to cut it like this, much less surface area. By cutting it like that, you have very little contact on this saw. It's going to make your blade last so much longer, guys. And I learned this the hard way, so don't think that I'm like trying to act like I know more than someone else. I'm just telling you from experience that cutting material the wrong direction, which this is the wrong way, if you cut this, you're going to shorten the life of this blade. It'll do it, but you've got a lot more material and a lot more force touching those saw teeth. So you've got 1, 2, 3, 4 teeth at a time, roughly, that are going to be into this blade, and you're basically trying to mill off the top surface of that as opposed to cutting it like this. Then you have an individual tooth in the blade at a time, much less material that you're cutting with each tooth, and it's going to make your blade last so much longer. This is 3-inch flat plate by 1/4 inch thick. So for this, you don't necessarily need your V-blocks to hold this in. So we can take that off. Let's set our material like right here. We'll take off about a ½ inch. Slide our clamp up, throw this forward, put a little tension, that holds it. If you wanted to put another one on there, this saw allows you the ability to do both. So you can clamp it again right there. This will come in handy lifting it up and down, this bar, when it comes into putting the material on the bias, when you're clamping square tube on its side as like a diamond. But I'll show you what this does. So we'll loosen this up, and you see how this works here, guys? And I just tighten this little set screw down. Now look at the position of these clamps, guys. Now the clamps are up higher on the material. So that's what this bar does. By moving this bar up and down, you can change the position of where you're clamping this at. Having it down at the bottom would have been absolutely fine, but we'll have it up here just for the heck of it. This is really loud, guys. You're going to want eye protection and ear protection. And you'll watch as I cut this, the chips will go into this little box section right here. And there's a little hole in the back and allows them to exit out the bottoms. Unlike an abrasive wheel is hot, there's sparks that fly everywhere. This isn't like that. This is nice and cool. The piece that you cut will just be warm, it won't be hot to touch, and there's a lot less chance of burning your shop down because there just isn't the sparks that are associated with an abrasive wheel. So ear protection, eye protection, and we'll get this thing cut. And another good thing, guys, the cords that they use for this tool is rubber. It's not that hard, plasticky cord material. This is a nice, flexible rubber. Feels like quality. All right, here we go. Not even hot, fresh off the saw. Look at that. Nice and smooth. And I know it's straight because we set the saw up straight. I've got some 3" by 3" 1/4 inch thick. Now the preferred way to cut angle iron is to set it in just like this. And they also give you a little diagram showing that that is the preferred way of doing it as well, and you'd want it on the middle setting so that this, basically the center of the saw is at the center of that peak. But that's not to say that you always have to do it that way, because what if you wanted to cope out a piece of this metal, meaning you're only going to cut one leg of it? Let me show you. So if you were to cope this out, meaning you're going to cut off this section here and here, you might want to cut straight down with your saw here and then come in with a wheel in to make this cut. And you just cut that piece going straight down, going into it easy, and just cut it all the way down. But we're not going to do that for here. We're just going to cut it off and do a straight cut. And this is the preferred way of doing it because you have less material in the saw at one time. And we also probably want to go with this as well, with the V-block on it to hold it down. Now we'll clamp these down to hold it tight against that back fence. We'll change our adjustment on the back. And that looks good. Let's go ahead and make our cut. Look at that. Immediately off the saw, I'm handling it. Just like that, guys. This saw cut is just smooth to the touch, and it's just warm to the touch. But look at the finish on that, guys. Does an awesome job. Like I said, no sparks flying all through your shop. Nice, accurate cut. You can also get these blades in different configurations for different materials. So this is a steel blade made to just cut steel. You can also get one that's made to cut just aluminum. You can also get one to cut just really thin material, and they make another one to cut stainless. Alright, so I've got some tubing, and let's say I want to cut a 45 on it because I want to make a box out of tube. That's something that is very realistic that we would do in the metal shop. So we set our material on the fence, clamp it down, and now we can set our 45. Look how great that is, guys. Love this feature. Push down on this with this backed off right here. Push down on this. It's got a positive detent at 45. Watch, I'll just push it over gently with my hand and you'll hear it snap in. There it is. Then I give it a little snug just like that to hold that in. So if that gets bumped, it's not going to move it out of whack. I've moved this to the forward position because that looks like it's best suited to be into the alignment of this material. But you also have to look at a couple other things because you don't want to go cutting your clamps off. So I am going to back off this clamp, move it over, and set it up right over here. If my material was a lot longer, I would be able to keep my clamp on this side, but it's not. So this is real world. This is what you do. Here we go. There you are, guys. Perfectly mitered joint. And the added bonus, if you were saving this piece and you need to put a 45 or any other number in the other direction, you just rotate the saw, make the cut. It's that easy, guys. This thing is awesome. But if you're just doing regular straight cuts, what you want to do, guys, is you want to cut it on the bias. And I've talked about this in a lot of my other videos. And what that is you put this little V-block piece on, just like this, and you want to cut it like that. So this is where this up and down system comes into play, so that you can get that piece of material fit perfectly in the cradle of that little V-block. But if you also notice, they're offset. So you can flip this around to get the fit up that you need without having to necessarily move this. Let me show you. And there it is, guys. Look how nicely that fits around that pad. Fits right here on the bias. There's a lot less contact points. This is very much simulating how we cut that angle iron. That's the best way to cut it. That's the least amount of material going into it. This is raised up one click on each side, and that was that setup. Once you guys use this for a little bit, you'll know exactly what you need to do to cut what material, especially if you work with the same material and you're making a bunch of cuts. This system right here is just going to be super fast and super accurate. I don't think I mentioned what to do if this saw was out 90 degrees, so if it was off just a little bit. What you do is you'd loosen that screw and that screw while leaving it still locked into the position that it's in right now, and you just tap this handle whichever way you needed to, and that would slide this dial either up or back in relation to that fence, and that would make it just correct. Once you got the blade perfectly 90 to the fence, then you just snug this back up. Easy adjustment to make this saw perfect. Alright, with that clamped in there, let's make this cut. Look at the nice cut that gives, guys. Straight, accurate, perfect. I don't even have to check it because I know it's perfect because the saw is perfect. But I know if I don't, people are going to say something. Try to give it every little opportunity I can to have light shine through it, and you're not going to get it. I know you guys are going to ask the specifications for this saw, so I figured this would be a great time to share them. As of right now, this minute of this video, this saw will run you about $849. You can get some promo deals and get some money off if you buy them through specific links. I actually have one of those links, and I'll put it down below if you guys want to check it out. If you buy it through that, it doesn't cost you anymore. Might save you a little bit and give the channel a little bit of a boost. So for plate steel, it'll cut 1/2 inch, stainless 13/64. If you're cutting it square, just like we're cutting it right now, this tubing, it'll cut 4 3/4 by 4 3/4 square tube. But if you're turning it on the 45, you lose some of the depth of cut. So that's going to get you to 4 inch by 4 inch. These are the little shavings that come out of the saw. They're very small, easy to clean up. Evolution actually has a little tool. It's like a little magnet tool. You just wave it around, then you pull it back and all the shavings fall off. I don't have one, but I'm definitely going to pick one up just because they're super handy. I've wanted one for a long time, and I don't ever think about it until I start getting into a project like this, and I'm like, wow, I need to get one of those tools. So this is my overall review of this saw, guys, and I can't say anything bad about this. This thing is incredible. I know I've mentioned it numerous times, but I just get all jacked up when I see something that just fits a need that we've all needed for so long. it's been a long time coming for somebody to finally do this, and I am just so thankful that Evolution did. Yes, it's a lot of money, I get that, but everything's a lot of money these days. All tools cost a lot of money. This is a lot of tool for the price, and I can say that I don't see me ever needing anything but this saw to cut metal. For everything that I do in my business, this cuts metal both ways. This is perfect for a cramp type shop. It will work great for a large type shop. This just really check marks all the boxes for me, guys, and this fixes any of the minute complaints that I had with this saw. Don't get me wrong, this is an awesome saw. If you guys are looking to go out and buy a saw and you don't think you need the mitering capabilities of that, buy this. I'm telling you, you guys will not go wrong with buying this saw. Awesome. Evolution tools are incredible things. Like I said, I got a bunch of them and I swear by them. But for me, in my business, this is ideal. Having something that miters, locks in at any degree, clamps down. This is kind of like the Cadillac of saws right here, guys. This is about as good as it gets. And I don't ever see myself needing anything more than this. So this is a one-time deal, one and done. And that's all there is to it, guys. I want to thank you for watching. Thank you guys for tuning in. There's new videos every Friday. I've got some upcoming repair videos. We got some mobile welding videos that we're going to be doing. It's just been super busy in the shop, and I got a lot of things going on in my life right now. Be sure to tune in, like, comment, subscribe. Until then, I will see you on Friday. Take care, stay safe, and God bless.